Hello, I'm Anna Mackay, and today we're looking at surds, and when you have to divide and you have a surd on the bottom, how to turn that into an integer denominator. So if we have 4 over 7 root 3 here, and you're interested in getting a whole number on the bottom, so no surd. So how are you going to get rid of that surd? What could you do to root 3 to get rid of it? Well, the way to get rid of a surd is to times it by itself. So if you have root 3 times by root 3, it would essentially disappear. But you can't just times that whole fraction by root 3 because then you're essentially changing it. What is the only thing that you could multiply anything by or a fraction by so that it essentially doesn't change if you multiplied it by 1? So if we can write out something to multiply this by that has root 3 on the bottom, then that'll help turn the denominator into an integer. So therefore we have to have root 3 on the top as well to make it the equivalent of multiplying by 1. So that will help us get it without the surd. Okay, so this here, as we said, multiply by root 3 on root 3. There. And therefore when multiplying fractions, you multiply the numerators. So essentially imagine that division line's just extended across. You multiply the numerators and you multiply the denominators. So that root 3 times by root 3 has turned into 3. And now our denominator is 21, so we have an integer denominator, which is going to make it easier when, in future, when we're using these things and we have to manipulate them in different ways. If you have an integer denominator, it's going to make your life much easier. What about 6 on root 5? So to get rid of a surd on the bottom, you have to multiply it by itself. But you can't just multiply by root 5, because that's changing the whole thing. Essentially, if you multiply by 1, you'd be fine. And the way to do that is root 5 on root 5. And therefore, we multiply the numerators, 6 multiplied by root 5, and you multiply the denominators. And root 5 times by root 5 comes out to be 5, and now we have an integer denominator. So that's just summarising what we've done there, that you multiply that by root a on root a. So that's fine if you've just got a number out the front here. What about another form where you have a surd on the bottom, but you have 2 terms essentially? You now can't multiply by root b on root b, because if you think about what would happen, your numerator will be fine. Yes, that root b, when multiplied by a root b, will cancel out. However, the extra root b is distributed with that a, and now you have a root b, and now you're faced with the same problem. So there's got to be a different technique to turn that into an integer, and the technique is to multiply by, so that's the equivalent of 1 because it's the same thing on the same thing. What do you notice? Here's the denominator here, and here's what you're multiplying by. Not quite the same. The sign has changed. What's that called when that happens? They are conjugate pairs. So they're the same terms, if you like, but different signs. And in this case, they're not only conjugates, they're radical conjugates, just for the official definition there. So let's put that technique into practice here. We have 5 over 3 take root 2. And so the technique is to multiply by the conjugate. So we look at the denominator, and you write that out, but you change the sign. Notice that the sign is the same for the multiplying here because you have to have what you're multiplying it by equal to 1. And then we're going to work out what this comes out to. So you multiply the numerators. So we've got 5 multiplied by 3 and 5 multiplied by 2. Might just write this out to show how we're distributing it. And then for the denominator, you need to be able to recognise that that will end up being the difference of 2 squares. So the middle terms would cancel out, and we have 3 multiplied by 3, so we have 3 squared, and it's a subtract. And the second term, root 2 all squared. Let's simplify that. The numerator, we have 5 multiplied by 3, that's 15, and then we have 5 multiplied by root 2, gives us positive 5 root 2 over the denominator. 3 squared comes out to be 9, and then this comes out to be 2, so we have 9 subtract 2, And then that whole thing is 15 plus 5 root 2 all over 7. And now we have our integer denominator, which is what we were after. So the next video in this series, we will combine 12B and C for indices and index laws. Have you subscribed to the channel? Please do. Thank you.